Here's another example that actually has some pretty cool mathematical properties. I have the sum n equals 1 to infinity of n to the n over n factorial. I don't know about you, but I would get a headache trying to integrate this thing. So I'm going to take a look at the ratio test. So I'll take a look at the limit as n goes to infinity of n plus 1 raised to the n plus 1 over n plus 1 factorial. There's my an. I'm sorry, my an plus 1. So I need to take this whole thing and divide it by an, which is n to the n over n factorial. And again, looking at this, these are all going to be positive terms, so I don't have to worry about this absolute value. So this is now going to be the limit as n goes to infinity. And when I flip these around, I'm going to line them up in a way that seems logical to me. This could be n plus 1 raised to the n plus 1 over n to the n times, now I need to do my factorials, this would be n factorial over n plus 1 factorial. Now I'm looking to cancel things out. I cannot reduce this because these aren't the same. The bases aren't the same. But the factorials will cancel. The n factorial will cancel with the n plus 1 factorial to give me only n plus 1. So now I have 1 over n plus 1. Well, 1 over n plus 1 will cancel with one of these. So this will just be n plus 1 to the n. Well, that's kind of cool because now what I end up with is a limit as n goes to infinity of n plus 1 over n. Both of these are raised to the n. That is equal to change this into a format you may recognize, the limit as n goes to infinity of 1 plus 1 over n to the n, and hopefully you recognize that as being e. Well, e is greater than 1, therefore the sum n equals 1 to infinity of n to the n over n factorial is divergent. Now, briefly, I want to go back to the idea of absolute convergence for a second here. I use the term absolute convergence when I use the absolute value sign. And a couple of the other examples that were convergent, I said was absolutely convergent. Well, the reason that absolute convergence is important is that if you have something that is absolutely convergent, then it will converge regardless of the order that you put them in, put all the terms in. Remember way back when I first started with this idea, 1 minus 1 plus 1 minus 1 plus 1 minus 1, so forth, etc. And I said, well, gosh, this is 0, this is 0, this is 0, so clearly this must converge to 0. Then I said, well, wait a minute, what if I did these? This is 0, this is 0, this is 0, so now it converges to 1 because I left one of these 1s out here. Or what if I move these around? I did 1 plus 1, and then I took this negative and threw it to the end of the line, so to speak, and then minus 1, plus 1, minus 1, plus 1, so forth. Now here's all my zeros. So now this thing sums up to 2. The point is, as I change the order of these, I can make it sum up to pretty much any integer I wanted. However, we did, as a reminder, we did look at this and determine that this is in fact divergent. But the point here is if I have something that's absolutely convergent, then the order that I add these up, I can shift it around any way I want, and it's always going to converge to the same thing. Something that's conditionally convergent may not be true. That may not always happen like that.